Project code ITPW51. Project title high efficiency isolated 3-port DC to DC converter for hybrid charging stations. Generally, in charging station having AC as a input, which will be converted into DC. This DC converter is given to the isolated converter because it will provide the galvanic isolation. Because without the isolated converter means when the input side having any fault, it will affect the battery directly. So the isolated converter provide the galvanic isolation between the input and the battery, and which will be connected to the battery. So this concept is a hybrid charging means for battery, some battery having the fast charging ability, some battery having the slow charging ability, fast and slow. So depends upon the two converter which will be designed with a single converter, that is the DC isolated converter for fast and slow charging. In existing concept already said that the DC is converted into AC. Sorry, DC is DC to DC converter using the isolated converter like DAB converter, dual active bridge converter. Dual active bridge converter having input side DC to AC conversion take place by using the bridge in between coupled inductor, and AC to DC operation take place. So the both side the bridge converter is used. So this is called a dual active bridge converter. This concept is a bidirectional converter. So this is only used in a existing concept. But existing have the drawback of size is increased, and because within the size our proposed concept capable of doing the fast and slow charging, but it is only the one conversion, DC to DC conversion for either fast charging or slow charging is only possible in existing concept. But in a proposed concept, the DC is given to the isolated converter. The isolated converter is a coupled inductor structure, so it will be connected to the one is bidirectional converter like for slow charging, controlled bridge rectifier, so controlled bridge converter circuit is used. So this converter is like a existing dual active bridge converter. This converter is a bidirectional converter which is capable of slow charging. But after that, here using the uncontrolled converter with the resonant series resonant converter, like here using the LC circuit in isolated converter in a coupled inductor. So resonant converter come controlled circuit, uncontrolled circuit, which is suitable for fast charging. So this side is unidirectional. So here the both unidirectional and bidirectional converters are used. So the both having some advantage and disadvantage. In case the bidirectional converter in a AC to DC, sorry, DC to DC conversion, it is only the for this purpose it is only unidirection. So no need not to reverse the power flow. So it will reduce the volume cost and control complexity also. This is a black diagram. DC source, single phase inverter, converted DC to AC. It is rectified. The AC is converted into DC. Again, this AC is converted to DC and connected to the battery 1, battery 2, uncontrolled rectifier for slow fast charging, control rectifier for slow charging. This the main application is e-vehicle application and energy storage application. This concept is implemented using MATLAB 2015 version. Here, MP-Lab software is used to feed the program to the PIC microcontroller in a hardware prototype for pulse generation in a prototype. The minimum hardware requirements like MOSFET, transformer to excite PIC microcontroller, and other active and passive components are used. Thank you.